Hello everyone, and welcome to my channel. This is an educational channel, and we look at some great theories of everything from the present, the past, even the distant past, and we try to go deep on them, show you the ins and outs, and how you can benefit from them in your life, especially in terms of shifting your paradigms and awakening to 5D consciousness. Today is our 476th video on the reciprocal system of theory from Dewey Bernard Larson. And Mr. Larson was an American engineer who lived in the 20th century, born in 1898, died in 1990. And around 1930, he had some epiphanies was working as an engineer, maybe a chemical engineer, some chemical company out west in Portland. And he was kind of working on a chemistry problem, trying to make his small contribution to the field. And eventually recognized that some of his findings were revolutionary, and that they led to a much broader set of solutions than kind of what he bargained for. And he answered the call, and he developed his theory over the next 30 years. And in 1959, he put out his two fundamental postulates about how he believed the universe operated. Just two sentences, kind of condensing all the major aspects of how he believed the universe operated. And then through a process of deduction, he developed his theoretical universe. Basically, what the universe would look like if my postulates were correct. And he wrote some books comparing his theoretical universe with the actual, so-called actual measured empirical universe of the legacy scientists, all the mainstreamers out there who had done many laboratory experiments to determine, various scientific processes and measurements, and compiled them in tables. Like, so for example, we're looking at this book here called Basic Properties of Matter from Mr. Larson. He put this out just a few years before he died in 1987. And this book is primarily on chemistry. And Larson develops equations for many of the basic properties of matter, like the melting point and the specific heat and the thermal expansion. And then he compares his results with the laboratory results that are compiled in various scientific tables. We are in chapter 8, close to the end of chapter 8 here, called Thermal Expansion. Now, Mr. Larson's theory is called the reciprocal system, and it's called the system of theory, because it's not just a theory, it's a system of theories. It's an intertwined, interlocking set of theories on every subject. Now, Larson didn't live long enough, even though he lived to be 92, didn't live long enough to extend his theory into every subject. But he extended his theory into many subjects. He's got books on chemistry and physics, astrophysics. He's got books on sections of books on many metaphysical subjects, including psychology and religion and metaphysics, philosophy, dream interpretation. He's got 2 books on economics. So he has a system of theory. It's basically one way of looking at things, and then you can plug it into whatever field you choose, including fields that Larson never explored. Some of his followers have plugged his theory into other subjects, even geochronology and meteorology and crypto history, conspiracy theories. These have all been explored by some of Larson's followers. Now, the basic idea, again, is laid down in the first 2 postulates. And the first postulate is really like what's particular to the reciprocal system. And then the second postulate is really kind of what's more accepted by the regular, normal, everyday scientists, just as a condition of being a scientist. And the second postulate is what Larson basically uses to derive the theoretical universe that he arrives at. He takes the prongs that are articulated in the first postulate, and then he uses the second postulate to run the first postulate through the second postulate in order to arrive at a theoretical universe. So the first postulate, again, the reciprocal system of theory, also known as the universe of motion, because Larson is one of the few scientists, but not the first, but one of the few scientists who attempted to build their cosmology on motion as opposed to matter, like the ancient Greeks, or energy, like some of the 20th century folks. So the first postulate reads that the universe is composed entirely of one component, motion, existing in 3 dimensions in discrete units and with 2 reciprocal aspects, space and time. Okay, so that's the first postulate. The second postulate is that the universe conforms to the relations of ordinary commutative mathematics. Its primary magnitudes are absolute, and its geometry is Euclidean. Okay, so you see the second postulate doesn't really contribute anything new. It's really kind of the old way of looking at things. Math works, geometry works, logic works. The first postulate is, very different than most scientists think of. And it has basically 4 prongs to it. The universe is made out of motion. Motion is the relationship between space and time. And space and time and motion come in 3 dimensions. Space and time and motion come in only discrete units. Now, I have fleshed out these reciprocal system ad nauseum, and I'm going to do it one more time here a little bit, but in the future, I'm just going to refer you to one of my previous 475 videos because I'd like to spend a little bit more time going through the actual text of Larson. But, there's a lot of kind of background information that you need to have before you can even start to kind of get into it with Larson, especially like in the middle of a chapter somewhere. And so I want to give the viewer the background information that's needed, but there's so much background information that's needed that at this point, I've given you really like 475 different versions of explaining how this works, and you could really choose any one of them. So I'm going to start to just refer you to one of my previous videos if you want to get up to speed on how the reciprocal system operates, and I might just give you a 1 or 2 minute explanation and then start getting into the text of what I'm reading. So kind of from here on in, at least as far as the reciprocal system is concerned, I think we're only going to go through this book, and maybe not even this whole book, and then we're going to go through one of his books on economics. I might not read that book either. I might just go for my notes. I feel the need, especially in this book and in some of the scientific subjects, to read Larson's books word for word, because I don't feel like I'm really in the place to interpret them. I understand the theory as well as I can so far, but my comprehension of a lot of the details is lacking for various reasons, most of which are on me. And but so I want you to be able to hear it coming, you know, from Larson, but I also feel like I need to be explaining these things to you for every video, and so I'm not going to do that starting tomorrow. I'm just going to go kind of get right into the reading. But so the first postulate really has these 4 prongs. The universe is made out of motion. Motion is the relationship between space and time. Space, time, and motion have 3 dimensions. Space, time, and motion come only in discrete units. When Larson's talking about motion, he's referring to a specific or generalized kind of motion called a scalar motion. This is a motion that has a magnitude, but it has no specific direction. You can model a scalar motion using a balloon that you put dots on. If you blow up the balloon, you will discover that all of the dots are moving away from each other, but they're not moving in any specific direction. Every dot is basically moving in every direction away from each other. And if you reverse that motion and you contract the balloon, then all of the dots will be moving toward each other. These are what Larson calls the progression, the outward movement. So it's a scalar motion. It doesn't have a direction, doesn't have a specific direction. You can call it in or out. And the outward motion of the progression is called the progression. The outward motion of that balloon surface is called the progression, and the inward movement is called gravitation. Now you have to accept the limits of the model there. It's missing a dimension there. You could also use something like raisin bread to make up the difference. As you put the bread in the oven and it rises, all of the raisins will be moving away from each other. And so you can think of it that way too. But so that is a scalar motion, and that's the motion that Larson basically constructs his universe out of. That is the source, the progression. And that outward motion is eternal and omnipresent. It is occurring at all times in all places. And it's occurring at a certain speed, and it is the source of everything. And this is something that you have to accept to be able to accept the reciprocal system. And to manifest anything, you basically need to turn that outward motion of the progression into the inward motion of gravitation. The gravitation is what implies matter, or is the evidence of matter. And so all matter gravitates. And so anything that is made out of matter is on the inward motion of that balloon. And so that turning that outward motion to the inward motion is done by reversing the motion. First by neutralizing the motion and then moving the motion inward. It has to be basically rotated. First it's reversed and then it's rotated. And the reversal is really called the photon. And then the rotation is of the photon, and that results in particles and then eventually atoms. And in Larson's periodic table, he uses 3 numbers. So you have your A number is your primary 2-dimensional rotation, your B number is your secondary 2-dimensional rotation, and then your C number is your 1-dimensional rotation in the opposite direction, which is optional. So every atom has a 3-number group in Larson's system. The 3rd number could be 0. The 3rd number could be negative or positive. The first 2 numbers are always positive, and they alternate. The first and then the second, and then the first and then the second. And the maximum that you can get for the first 2 numbers is 5. 4 plus 1. 1 is for the initial level, because there's always an initial level when you have the progression. The progression is always there. So there's always this underlying motion in the universe. It's always there. This is what Larson would call the empty universe, or the universe at rest. So in a universe of motion, the universe at rest is moving outward in all directions at all times. So then we have motion, and motion is the relationship between space and time. So this is implying a reciprocal relationship. Motion is basically a fraction, with space or time as the numerator and time or space as the denominator. Space and time are reciprocals of one another, which means that they have identical properties. Whatever property adheres to one also adheres to the other. Not at the same time, but in their totality. And space and time do not have an independent existence. They only exist together in motion. And space and time have 3 dimensions. You can see this in what Larson calls coordinate space and coordinate time. Coordinate space is something that we're accustomed to. 3 dimensions of time, 3 dimensions of space in a still frame. You know, X, Y, Z coordinates. Space is stationary, but time is still moving. Time is moving in a scalar manner. It's always getting later and later and later, but in no specific direction. This is what Larson calls the spatial reference system. The spatial reference system is coordinate space and clock time. Gravity has slowed or stopped the progression of space. When you go back to this progression, you know, the progression is space and time, outward in space and outward in time, step by step by step. But if you reverse the progression in one aspect, in space, then you get coordinate space, 3 dimensions of space in a still frame, and you have clock time. time is still progressing. So you've reversed and neutralized and rolled back the progression in one of the two, but not the other. And by the reciprocal postulate, there is also theoretically a place where you have coordinate time, 3 dimensions of time in a still frame. Time is stationary and has x-like, y-like, and z-like coordinates. But space is still progressing. Space is still scalar. Everything is getting farther and farther and farther apart, but in no specific direction, like on the surface of an expanding balloon. And Larson refers to that as the temporal reference system, and the temporal stationary reference system. So we've got these 2 reference systems, 3 dimensions of space and 3 dimensions of time. But in total, we have 3 dimensions of motion. And it only requires 1 dimension of motion to fully exhaust those 3 dimensions of either space or time. So the spatial or temporal reference system is not sufficient to describe 3 dimensions of motion. And so Larson uses the moving reference system, the progression, but it's the progression at a certain rate. And that rate comes from the discrete unit postulate. All of our scientific quantities come only in units. As I was saying, all motion is a relationship between space and time, basically a fraction with space or time as the numerator and time or space as the denominator. And speed is the most basic kind of motion that we know of. The car is moving 10 miles per hour, 10 miles of space in 1 hour of time. Space over time is speed. But all of our other scientific phenomena are also forms of motion. Matter is a form of motion. Energy is a form of motion. Force is a form of motion. Electric charge is a form of motion. Viscosity is a form of motion. Pressure is a form of motion, and so on. And they all have their space over time or time over space signatures, keeping in mind that they can go up to 3 or really 6 dimensions, like density. Density is time to the 3rd power over space to the 6th power. And that's really because density is mass over volume. And mass, matter, is time to the 3rd power over space to the 3rd power. And volume is space to the 3rd power. So when you multiply them together, you get time to the 3rd over space to the 6th. And that's density. And that is a kind of motion. It's a relationship between space and time. And so Larson has this moving reference system that he calls the progression of the natural reference system. There's a stationary spatial reference system, a stationary temporal reference system, and then there is the natural reference system, the system that the universe actually conforms to. And that is where Larson makes his measurements from. Whereas legacy science makes their measurements from 0, from stationary space. Okay, now, so the discrete unit postulate, everything comes in units. Gravity comes in units. Matter comes in units. Acceleration comes in units. Force comes in units. Energy comes in units. Speed comes in units. And in this case, we have the progression at unit speed, 1 unit of space per 1 unit of time. And that space over time is speed. 1 over 1 equals 1. Unit speed is 1 unit of space over 1 unit of time, which also turns out to be the speed of light. So that is the progression. That is the empty universe. That is the ether. That is the 0 point. That is the state of rest of the universe, is to be moving outward at the speed of light in all directions from all locations at all times. And then that is the datum from which you make your measurements. And what that also means is that half the universe is actually moving faster than the speed of light. Half of the universe is moving slower than the speed of light. The speed of light is a boundary between two different sectors of the universe that Larson refers to as the cosmic sector, the faster than light sector, and the material sector, the slower than light sector. In the cosmic sector, you have coordinate time and clock space. In the material sector, you have coordinate space and clock time. They are reciprocals of one another. So even though the legacy scientists know nothing about the cosmic sector, they can take what they know about the material sector and extrapolate it to the cosmic sector because they are reciprocals of one another. Also within each one of the cosmic sector and the material sector is a subregion, what Larson calls the time region in the material sector and the space region in the cosmic sector. And this is, again, due to the discrete unit postulate. Space, time, and motion come only in discrete units. You have to have a full unit of space before you have space, and same with time. And so if you have atoms or particles that approach each other to 1 unit of space, they can't move any closer in space. So what they do, because 1 unit is the smallest that you can get. And so instead they move outward in time. Instead of inward in space, they move outward in time, which by the reciprocal postulate is equivalent to outward and inward in space. And so we see it as inward in space because we are anchored to a spatial reference system. So Larson calls this the time region. That's the region inside 1 unit of space. Now, our perception is slightly distorted or very distorted when we look into this region, but we can look into the region, but we have to adjust our findings because what we see in equivalent space is a 2-dimensional region as opposed to 1, and it is reduced by what he calls the interregional ratio, which is basically the amount lost in the translation as you're looking from one sector of the universe to another. Now, the same thing holds true in the reciprocal sector, the cosmic sector, except that's called the time region or the space region, which is within 1 unit of time. And when they approach each other to 1 unit of time, then they can't move any closer, so they move outward in space, which is the equivalent of moving inward in time. Okay, let's try to read here for a few minutes the end of this chapter. Most of the rare earth elements have the 1 unit expansion coefficient, 5.2 times 10 to the minus 6 per degree Kelvin, at the initial level of the second segment of the curve, although their melting points are in the range where coefficients of 2, or in some cases 3 units would be normal. The reason for this, the only deviation from the general pattern in the expansion curves of these elements, is as yet unknown, but it is no doubt connected with the other peculiarities of the rare earth elements that were noted earlier. The electronegative elements of division 3 follow the regular pattern. The lowest melting point in this group is that of mercury, 234 degrees Kelvin, well below the lowest value for any of the electropositive elements investigated. But this descent to a lower melting point does not introduce any new behavior. The upper segment of the expansion curve for mercury, defined by the empirical data in figure 15, definitely terminates at the 4 unit level, 20.7 times 10 to the minus 6 per degree Kelvin, as required by the theory. Thus, the theoretical relations are applicable to the full temperature range of the first 3 divisions. As noted earlier, the borderline elements of division 4, those with negative electric displacement 4, are capable of acting as members of either division 3 or division 4. The expansion curve for lead follows the normal division 3 pattern. The lower borderline elements, tin and germanium, have curves in which the initial levels, like those of the rare earths, are lower than the values corresponding to the melting points. Otherwise, these curves are also normal. Very little is known about the expansion of the elements of negative displacement below 4. The theoretical development has not yet been extended to a consideration of the effect of the strongly electronegative character of these elements on the volume relations, and the empirical data are both meager and conflicting. Division 4 situation is part of the general problem of anisotropic expansion, a subject to which the reciprocal system of theory has not yet been applied. The measurements previously cited that apply to anisotropic crystals were made on polycrystalline material, in which the expansion in different directions is averaged as a result of the random orientation in the aggregate. Both this issue of anisotropic expansion and the application of the thermal expansion theory to compounds and alloys are still on the waiting list for future investigation. There is no reason to believe that such an investigation will encounter any serious difficulties, but for the present, other matters are being given the priority. Okay, that's the end of the chapter. And chapter 9, the next chapter here is called Electric Currents. And that's what we'll start with when we resume tomorrow. And again, I won't be explaining the reciprocal system just for a moment, and I'm going to get right into the text. Now, I'm sure that you didn't understand quite a bit of what was said there, especially if this is your first video with us here, but I do like to read it into the record so that any real studious person can pick up on it. And so that's what I did there. You're going to have to watch my old videos and watch many of the new videos and the old videos maybe to pick up on exactly what's being discussed. You know, in order to be able to move on, I'm going to have to, at some point, assume that you have a certain amount of understanding and just refer you to previous videos. So that's where we're headed here in the next little while. And stay tuned tomorrow for some talk about electric currents. And thanks for tuning in.